Hello everyone, welcome to today's video. So before we proceed forward solving this question, I would like to show about my community that I have recently created. So in this community, I'm posting regular off-campus opportunities. It might be placement or internships or any information about hackathons or webinars. So these were some of the opportunities that I posted yesterday. So you could see that, and also one of our community member has actually applied to the company Propel, and he has already received a response from them their end as well. So I highly suggest you people, like those who all are looking for off campus opportunities, to join this particular community, because I'm posting at a regular basis, on a regular basis. Okay, so I'm putting a target of posting at least 6 to 8 per day minimum. Okay, so it might go to 10 and 12 maximum. So these were some of the opportunities that I posted yesterday. And also those who have already got placed, so I would also suggest them to join, because there might be better opportunities coming up for you people in this community. And also do consider sharing this with those who are actually looking for such opportunities. Okay, so the link to this particular channel is given in the description. Please go through it. Okay, so let us start the problem for today. So today's problem is merge two sorted linked lists in reverse order. So this is a medium level question and is a problem of the day on Geeks for Geeks today. So what is the question saying? Given two linked lists of size n and m, which are sorted in non-decreasing order. The task is to merge them in such a way that the resulting list is in non-increasing order. What do they mean by when they say non-decreasing order? So the elements are like increasing, but at the same time same equal elements might be there. Okay, so that is what they say when they say non-decreasing. So some of the elements might be equal and they are following the increasing order pattern. But at the end of the day, you're asked to merge the sort list, merge these two lists and give return the list that is in a non-increasing order, that means decreasing order. But there might be elements in the middle that is like equal to, like two or three elements that are same. Okay, so that is the case. So these are some of the examples given. We'll go through them, and these are the expected time complexity of n plus m and spaces of 1. We are going through the same solution, and these are the constants, and these are the company tags and topic tags. Okay, so now let us understand this question in brief. What are they actually expecting us to do? So this is the example that has been given. If you can carefully see what is the output here. So this is in a non-decreasing order. Okay, non-decreasing order. This, what do you mean by non-decreasing order, especially when I say this? So this is a non-decreasing order, 1 2 2 2 3. This is not an increasing order. Okay, they're following an increasing pattern, but that doesn't mean it is an increasing order. Okay, because we have 2 2 2. Are all like, is 2 greater than 2? Is 2 greater than 2? No, it is not. So we cannot say it is an increasing order. That is the reason we say it's a non-decreasing order, because there is no decrease anywhere. At least that is the reason we say non-decrease. Similarly, when they say non-increase, okay, when they say non-increase, the thing might be like 3 2 2 2 1. Okay, this is the pattern. Okay, I hope I'm able to I'm making some sense. So this is the thing that has been given. This is the first linked list. Let me erase this part first. So yeah, this is the first linked list, and this is the second linked list that has been given. Now compare the values 40 and 20. What is the maximum value? 40. So put that first. And then this is done. Okay, this is out of the picture. Now come to 15 and 20, because 20 hasn't been used yet. Which is greater? 20. So put 20 here. Cut off 20. This is out of the picture. Now what is there? 3. So who is greater? Out of 3 and 15? 15. So put 15 here. 15 is out of the picture. Now what is there? 10 and 3. Comparing 10 and 3. Which is bigger? 10. So put 10 here. 10 is out of the picture. Now what is 5? 5. So you're 5, or you're on 5. Okay, so comparing 5 and 3, which is bigger? 5. So this is also out of the picture. Now is there anything left in the list 1? No, nothing. It's empty. List 1 is empty now. Okay, list 1 is empty. So what all things that you have in list 2, you'll be putting that here. Okay, so you have 3 and 2, just put that 3 and 2 here. Okay, so you're making sure that you're giving it in a non-increasing order. That is the question. Okay, so please go through it. The last, I mean the final resulting list, is it should be in a non-increasing order. Great, I hope I'm making making sense. So that is the reason we have inserted in the reverse order, like first 3 and then 2, okay, and then 2. So I hope you people have understood why did we get this particular output. Now let us discuss the approaches. Okay, what is the first approach? What is the first approach? That starts from the brute force itself, the naive approach. See, some of you might be puzzled, how am I able to come up with these ideas? Not just me, there are hundreds and thousands of people who could solve these questions, because we had some rigorous practice on linked list previously. Okay, so we had solved some good number of questions, maybe 40 or 50, around 40 and 50 good number of questions. We spent some good amount of time towards each and every question. That is the reason we are able to easily solve this, and the same thing happens with you as well. So if you could spare some basic enough amount of time on the basics first, if you could actually understand the basics properly of the linked list, how are they functioning, how to go from back to first and first to back, if you can be comfortable on those fundamentals, all these things will be a cakewalk to you people. Okay, so just spare some good time on fundamentals, you'll definitely see that you'll be able to solve these questions, these type of questions very easily. Even maybe less than 2-3 minutes you might be solving this type of questions. Okay, just that you need to write the code, only coming with an intuition and logic would be very easy. So spare some time on fundamentals. Okay, so my videos are not only confined to problem of the day, explaining that and putting the solution and I'm done. It's not like that. I would like to see an overall emphasis of growth in terms of DSA solving and etc. So that is my main priority, and that is what I keep it at the first task. Okay, so how do you solve this? Coming with the brute force approach. Okay, so coming with the brute force approach, what is the brute force approach that you can come up with? First, as you can clearly see, the thing is you can actually reverse this. If you can actually reverse this, what would happen? 40, 50, 10, 5. And if you can reverse this, what would happen? 23, 2. Okay, now you reverse this. Now you can start from this particular starting point. Okay, now you'll compare what is which is bigger out of 40 and 20. 40 is bigger, so you'll put it here and you'll push this blue arrow to the next one. So now you'll come here and you'll compare these two, which is bigger? 20. So you'll put 20 here and now we'll push this arrow to here, 3. Now you'll compare 15 and 3, which is bigger? 15. So you'll put that 15 here and you'll move this blue arrow to here, so now again you have come to 10. Now you'll compare 10 and 3, which is bigger? 10. So you'll put 10 here and you'll put your blue arrow here, so coming to here. Now you'll compare 5 and 3, which is bigger? 5. So you'll put that 5 here, and once you're done, there's nothing like if you put your blue arrow here, blue arrow will actually scold you because there's nothing here. Okay, it will actually give you a lot of bad words. So please don't do that, because you have come to end of the linked list, there's nothing there. So now what is there? Only left this blue arrow is there. So now you'll put all those things here, so just put on till you go to the null. Okay, till you go to the null, that's it. So now you have got the required output. So what are you doing here? So the first thing is reverse list, reverse both the lists, reverse both the lists, and then merge them. Okay, merge them by traversal. Okay, just do this. Okay, then you'll be able to solve this very easily. But what is the extra thing that you're doing? Okay, extra thing, the common man approach. This is known as common man approach. If you're an intelligent person or someone who did rigorous practice, you can able to solve with this question in an optimal approach. But if you are a common man, okay, I was also a common man earlier, so I use the same approach, like I reversed these tests and then merged using the traversal. Okay, but what is the most optimal approach? So instead of actually going from reversing and then starting with these two, why don't you start with an empty list? Okay, and then why don't you start with empty list and then start from the forward itself, because you cannot start from here, do not have this access to 40 and 20 or 3 or 15 at the beginning. What is the access that you have at the beginning? 5 and 2. So now you construct from the right side to left side. Okay, construct your linked list like this, linked list like this. I know what I'm saying when I'm telling you construct your linked list will be like this only. So A, B, C, D, E, F. Let us assume your final linked list is like this. Okay, your final linked list like this. A's next is pointing to B, B's next is pointing to C, C's next is pointing to D, D's next is pointing to E, E's next is pointing to F. Your final linked list will be like this only. But what am I trying to tell is, find F first. Okay, find F first and then find E, so that E is next you'll put F. Okay, and then find D, so that D is next you'll put E. Find C, so that C is next you'll put D. Find B, so that you'll put B's next to be C. And find A, so that you'll put A's next to be B. And finally you return this A. Right, so we are constructing we are constructing from right side to left side, but the pattern of the linked list, the next pattern that is there, that will remain the same. A is B, next is B, B is next is C, that will remain the same, but we are constructing from the right to left. Okay, that is the gameplay here, that is the whole approach that is there here. But how are we going to do it? That is the task. Okay, so let me just erase these things. Oh, what did I write, man? And this doesn't go. This is the worst problem I'm facing since my childhood. Okay, I'll just. Oh my god. Okay, now I'll open it once again. It went off. Okay, so I'll just erase these things first. Um, Okay, so how are we going to do this? So only thing that we have right now is an empty list. This is a brute force. I hope you people have understood. Now let us, start this. I'll just erase these as well. So I hope you people have made a note of what is the brute force. I'll write the optimal now. Okay, optimal. What is the optimal approach? What is the first thing that we have? Okay, I'll even write the linked list for your better reference. 5, 10, 15, and 40. We'll use the same example only. 2, 3, 20. Okay, now what is the first thing that we have? What is the first thing that we have actually designed? The last part of the linked list. Okay, we have already decided that we'll be constructing from right side to left side. What will be the last one? The empty list, isn't it? The empty node or the null node, right? That is for sure. This is what we'll have now. Now what is the thing that we have access to? 5 and 2. Now you need to figure out what will be to the left of this, like whose next will be the null. Okay, so your this particular thing is like your present is this here. Okay, your present is this, and your present is actually null. It's an empty vector, empty node right now. Now you're deciding or you're seeing an husband for this null. Okay, so you'll be having an husband here and this is a wife. Okay, assume this is an husband and wife. So you're looking out for husband. So husband property is husband's next will be the wife. Okay, now you're looking out to for an husband. Who would be the husband here? Who will be the husband here? The smallest of 5 and 2, isn't it? The smallest of 5 and 2 will be the husband, undoubtedly. So if you put greater, then it will kick you. You must put the smallest of 5 and 2. What is the smallest of 5 and 2? 2 is the smallest. Okay, so you have got the husband to your, you have asked, you have got the husband to not your wife, this particular wife. Okay, this particular girl or female. So this particular null node, you have got the husband. So now this fellow is gone. Now this fellow is out of the picture. Now you need to put your blue to this particular thing and now compare 5 and 3. Okay, now compare 5 and 3. Now this fellow will be converted into wife. Okay, so please don't get into genders and all. That's very complex theory. Just just for better understanding, I'm telling this. I've took a wrong example, but still I think it's making some sense. Now we have come to this particular thing. Now you'll be seeing out of 5 and 3 who will be an husband or partner to 2. Okay, so who will be an husband or partner to that least among these two? So what is the least among these two? 3 is the least. So for 3 you'll be mixing up like this. So 3's next would be 2. But how are we actually going to do this? How are we going to actually do this? That is where the code comes into the picture. Okay, so firstly you'll be I'll just transfer this all these things here. So yeah, so firstly what you are given with this particular present. So that is what you have present, you have null, and now you're traversing both these. If you find this particular, the first one to be lesser than the second one, okay, if you find this first one to be lesser than the second one, first take temp and store this particular first fellows next. Okay, in which case am I talking about? First one. Okay, this is okay, let us assume this is first node and this is second node. Okay, let us assume this is the thing, first node and second node. If your like write this first case, second node is less than or equal to first node data. Okay, if this is the case, then what we'll do is take temp and store this particular second nodes next. Okay, second nodes next, second nodes next you store. Okay, second nodes next you store. Now what is the next step that you're going to do now? Because now your ultimate goal is to connect these two with your present. Okay, because now you have figured out this fellow is the smallest out of the first and second, so connect these two. So how do you going to do? Seconds next you will be putting as your present. Okay, seconds next you'll be putting as present. Now you have connected this two and this connection has been done. Now you need to update your present to this fellow, isn't it? Now you have to update this present to this fellow, so that your next this fellow will become the wife and you can find a husband to this. So your present would be equal to second. Okay, your present would be equal to second. And after all doing this, after doing this, what is the final step? Now we have updated this fellow. Okay, now you have updated this fellow. Now what you need to do, this now you need to compare these two, isn't it? Now you need to compare these two. If you do not compare, how is that going to, how would you go, how will you be extending yourself, right? How will you be traversing yourself? So now you need to update yourself. So how you will be putting your second would be equal to the temp. Okay, so that we have stored here the second. So now your second, this fellow would be the second now. Okay, now we will compare. So where till which point it will go, either one of them goes to the end. Okay, either this fellow must exhaust or this fellow must exhaust. I mean, linked list must exhaust. If this is going to be exhausted, so what are the remaining things that are there, you'll put it in the same fashion to the present thing. Okay, and if this is remaining, this is not remaining in this case, these are, because these are three only, these are four nodes, so this fellow will get exhausted first and there'll be one node left, you'll be putting it in the same fashion. I hope you people have understood. The same thing I've put in the code. Okay, so if you're not able to understand this, watch it once again, or put it on the paper. You'll be getting a better clarity for sure. I've explained things in a very easiest manner, super examples, interesting examples. Okay, so the same thing I've put in the code if you're for your reference. So first point, if node 1 equal to null and node 2 equal to null, return null. Okay, that's for sure, because your n and m can go from 0, so both of them can be empty linked list. Now first, node present equal to null. Now if node, while node 1 not equal to null and node 2 not equal to null, if node 1 data is less than or equal to node 2 data, you can compare with this first example. So first take node temp, that to be your node 1's next. Okay, node 1's next, and now put node 1's next to be your present, the same thing that we have done. So first store your next, and in the next you put your present. This is the marriage that you're doing. Okay, the marriage that you're doing, this is the marriage or linking. Okay, marriage is fine, marriage is good instead of linking. Now your present is up node 1. Now you're updating. This means your wife turn chichi, your husband. Okay, your husband turn to wife, husband turn to wife. Okay, and now your node 1 would be temp, because now, because you need to traverse, right? Your work is not done, you must complete the whole linked list. So whatever updation you do, in this case you're updating, dealing with node 1, because node 1 data is less than or equal to node 2 data. So now your node 1 will be temp. So this is like for further traversal. Okay, for further traversal you need to update. But what if your node 1 data is not less than or equal to node 2 data? That means node 2 data is less than node 1 data, right? So it's the simple thing, you will be writing here as well, the same thing you'll be writing here as well, just that instead of node 1 you'll be putting node 2. That's it. And now after doing this, either one of them will be exhausted. Either node 1 linked list 1 will be full or fully traversed, or linked list 2 will be fully traversed, or both of them will be fully traversed. Let us assume only linked list 2 has been fully traversed and linked list 1 is still there. So the same code, write it here as well. Okay, so first node what you did, so this particular thing, the same things, because we need to put it in a, this non-increasing fashion, you still need to follow the same pattern. Okay, and what if your node 2 still, no, like linked list 2 nodes are still there, then follow the same thing. Okay, then write the same thing. I hope I'm making sense. So whatever the thing that we have written here, same thing you must also write here as well, because we are traversing from the left to end, but we are constructing from right to left. So this is the pattern, how do you construct? Okay, so finally return the present. That's it. So very easy, very simple, to be honest, and I kept it in a very easiest manner. I hope so, because if I'm standing in your position, then I would definitely understand this approach, because I've explained it in such a way, grassroots level, everything I've written. So you can even go through this code thing that I've written, go through this dry run once again, so that you people will get some better clarity. Okay, so that's it guys for this today's video. And also you can see this time complexity is O of n plus m itself, and auxiliary space is O of n. And for your reference, codes in C++, Java, Python are there in the description. Go through them, and also do consider joining the WhatsApp channel if you're looking out for some excellent off-campus opportunities. Okay, so that's it guys. Thank you for watching. Stay tuned.